Hello, this is lesson 8.8 for Algebra 2, Approximating Irrational Roots. Today we're going to look at how you can graph some of these polynomial functions that we've been working with. There are some sophisticated ways to graph these. We're going to do a very basic way of graphing today. We're going to just be focusing on a t-chart. So we're just going to use the t-chart, plot the points, and then make a smooth curve to connect the points. And then we're going to talk about what kind of information we can get from the graph that we draw. If you have your graphing calculator with you at home, you can use your graphing calculator to help you with the t-chart and to kind of double check that your graph looks the way you see that it should look on your screen. But you're still going to be plotting these points by hand. There will be one question on the test where you have to make a t-chart, fill it in, and then make a smooth curve by connecting the dots on the graph that's provided. So make sure you practice this one on graph paper. So in 8.8, it talks about real roots of an equation. Remember that the real roots of an equation are the same as the x-intercepts of the graph of the equation. We've talked about this a lot. Every time I've talked to you guys about solving for x, I've reminded you that when you're solving for x, you're looking at where that graph would be touching or crossing the x-axis. So we can use the graph to estimate the roots. Sometimes it's going to cross really nicely right at one of the intersections of one of these corners on your graph paper, but sometimes it might fall somewhere in between. So if it's falling in between, like maybe right there or maybe right there, we're going to talk about how you can approximate what the answer to that graph would be. All right. In your book, they want us to approximate to the nearest half. So we're going to be kind of guessing on some of these. There is a way that your calculator can give you more precise answers, but I'll have to show you guys how to do that when we're back together again in person. All right, so for our first example, use a graph to estimate to the nearest half unit the roots of the equation. So use a graph to estimate the roots. All right, our equation is going to be x cubed minus 9x plus 9 equals 0. All right, we're going to make a table. For your test, I am going to give you the x values that I want you to use in the table, and you're going to fill in the y values. That just makes it easier for me to make sure that I can grade these efficiently. But when you're making a table, especially if you have a table function on your calculator, you want to pay attention to the y values. When a y value on a table is changing from negative to positive and positive to negative and negative to positive, those are places we're going to be crossing back and forth across the x-axis. We are particularly interested in those spots, the places where it's crossing the x-axis. So if you're scrolling through a table trying to decide which x values you want to use, pay attention to the places where the y value is changing. All right, also remember with polynomial functions, some of these numbers can get really big really fast. So sometimes you might have to adjust the scale on your graph. You might want to count by 2s or even by 4s or 5s or something like that. For this one, we're just going to go from -4 to +3. So -4 to +3. You can plug each number in by hand and solve to get your y values, or if you have a table function on your calculator, you can plug in your equation and use the table function of your calculator. So we're going to have -19, 9, +19, 17, 9, 1, -1, 9. So we're particularly interested in places like this where it goes from a negative y value to a positive y value. Somewhere in here, it crossed the x-axis. That means somewhere between -4 and -3, it crossed the x-axis. Then you go down here from +1 to -1, it crossed over again. So that's going to be somewhere between 1 and 2. And from -1 to +9, it crossed over again. So that's going to be somewhere between 2 and 3. So we're particularly interested in those spots on our graph. All right, for our scale, our y values have to go from -19 all the way up to +19. I'm going to count by 2s. And then for the x-axis, we just have to go from -4 to +3. So I'm just going to count by 1s on that one. So I'm going to need a nice long x-axis. I'm sorry, a nice long y-axis. Because I'm going to be going from -19 all the way up to +19. So I'm going to start here, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0. All right, so there's my axis. Counting by 2s backwards. These are the things we're doing for fun right now. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so a couple of marks to let a reader know that I've changed my scale. So on the test, if you're using a scale other than 1s, you need to mark it so I know what you're counting by. On my x-axis, I'm going to count by 1s because this one doesn't have quite the spread. Okay, remember, it's okay to have a different scale on your x-axis than your y-axis as long as you're counting by the same unit all the way across for x, and then you're counting by a constant unit all the way down on y. Then we just have to plot our points. So we've got -4, -19. All right, and then -3, 9. -2, 19, -1, 17, let's see, so that's 18. Uh, 0, 9, 1, 1, 2, -1. And 3, 9. 2, 4, 6, 8, 9. Oops, I think I made that one a little too high. All right, so we're kind of all over the place here. We're going to use a smooth curve. We want to move from left to right. So we're going to come up this way, down smoothly through this, down smoothly through this, and back up through that. That's the ultimate goal. Now, I can't necessarily connect the dots in that order and make it look nice, so I kind of plan out what I'm going to do, and then I just do sections of it. All right. A little wonky right there, but you get the idea. We want a nice smooth curve. All right, now what we're interested in is we're focusing on these places where it's touching or crossing the x-axis. So for this one, just like the table predicted, it's crossing between -4 and -3. We want to go to the nearest half unit. I'd say that's really close to -3.5. So I'm going to say x equals -3.5. And then over here, I'm crossing between 1 and 2. It's closer to 1 than it is to 1.5, so I'm going to call that one 1. And then it's crossing between 2 and 3. This is the part where I got a little off. I'd say it's maybe closer to 2.5. You're just going to have to use your best judgment on that. We're trying to go to the nearest half unit on the x-axis of where it's crossing the x-axis. So I'm saying -3.5, closer to +1, and then close to about 2.5. This was a third degree function, and it had 3 places where it crossed the x-axis. It has 3 real solutions. Now, it's possible with a third degree function that we could have had 1 real solution and then 2 imaginary solutions. Those imaginary solutions will not show up on the x-axis. So in our case, we have 3 real solutions. All right, let's look at one more. we're going to do the same thing again. We have the function is p of x equals x cubed plus 2x minus 8. And we are going to graph the function and look for the places where it touches or crosses the x-axis. For this one, my x values are going to go from -2 up to +3. Again, I'm going to give you a table on the test that I want you to fill in. I'm going to provide the x-axis, the x values for you. So -2, -1, 0, 1, 2, 3. And then when we plug these in, we're going to get -20, -11, -8, -5, 4, and 25. If you don't have your graphing calculator with you, or if you don't have a graphing calculator, there's a website called Desmos.com. It has a free graphing calculator, or free graphing software. You can type in an equation and then it will draw the graph for you on your computer screen. So if you're wanting to check your graphs at home, Desmos, DESMOS.com is a great resource for you to be able to look at these graphs if you don't have a graphing calculator. All right, on our x values, we're going to go from -2 over to +3. For the y values, we need to go from -20 up to 25. So for the sake of space on this one, I'm going to count by 4s because that's a pretty broad range. All right, so I'm just going to put this here. I don't know if I can count by 4s backwards, y'all. All right, we've got -4, -8, -12, -16, -20. Then we're going to go up +4, 8, 12, 16, 20, and 24. On my x-axis, I'm going to go by 1s. So that's 1, and that's -1. All right. For the points, I have -2, -20. -1, -11. We're approximating here because we got to pick between -8 and -12. So -11 is going to be really close to -12. 0, -8. 1, -5. That's going to be just below -4. 2, 4. And 3, 25. That's going to be just above 24. All right, so this one we've got this nice smooth S curve. So we're going to come up through here. Looks like this. Okay. For this particular function, we have one place where it's crossing the x-axis. So we're just going to be approximating this one solution. The other two solutions would be imaginary solutions, so they're not showing up on our graph. Now, you might want to zoom, you can zoom way out, make sure it's not curving back up somewhere over here, or dropping back down somewhere over here, but it shouldn't be. This should be your curve right here. All right, so we've got between 1 and 2. That one looks almost exactly like it's right at 1.5. So I'm going to call that one x equals 1.5. Notice on the table, from the y value here changes from negative to positive. So that means I was expecting to have an answer between 1 and 2. Somewhere between 1 and 2 on the x-axis is where it should be crossing, and it happened to be really close to 1.5. So use your table as a guide to show you where you should expect this to be crossing. This is the end of the chapter for us. So after you finish doing these graphing problems, you'll be working on the test review that's in your packet. It's a worksheet. Work through those. You probably will use a separate sheet of paper for that one. The test is going to cover a lot of synthetic division. You're going to use synthetic division to solve equations. Sometimes the roots will be given for you so that you know where to start, and then sometimes you might have to make a list of possible roots so you know where to start. And there will be one graphing question on the test. One question from today's notes. I will give you a blank graph. and an equation, and I will give you a table with the x values already selected for you. So you'll have to fill in the y values, plot the points, and then smoothly connect them with the curve. If you have any questions, you can email me at my school email address. That's the official form of communication for this time that we're working from home. My school email address is on the email that was sent out by the school, so you can check there. My office hours are Mondays and Wednesdays from 10 to 12, so that's when I'm answering questions. Make sure your email is in there by Monday morning at 10 so I can answer it for you. Any questions, please reach out to me or reach out to each other. I know you guys know how to get in touch with each other, so if you have questions, you guys help each other out. Okay? Stay healthy, my friends.